Hi, welcome back to my class in Advanced Statistics. For today, we will take up simple random sampling. One of the sampling techniques that we learned in Statistics 1 or Basic Statistics is random sampling. And the other sampling techniques are convenience sampling, stratified sampling, purposive sampling, cluster sampling, and quota sampling. But among the sampling techniques, it is known that random sampling is the best sampling technique to use because it gives each member of the population equal chances of being selected as to be part of the sample. Now, if you are given the population and you know the elements of the population and you want to select a sample of elements from this population, you can make or select different samples from this population. If these samples have the same equal chances of being selected, then the sampling is known as random sampling, or more specifically, simple random sampling. And the sample obtained from the population using simple random sampling is called simple random sample. We take an example. Consider the following problem. From a population of 4, a sample of 2 is to be selected. Letter A, how many different samples can be selected? Letter B, list the different samples. Letter C, what is the probability of selecting each sample? In this example, the population size is 4. But in reality, the population size can be a very large number. But for the purpose of demonstrating the concept of simple random sampling, we take the population size as 4 to simplify the discussion. Hence, for this example, the population size denoted by capital N is 4. And from this population with 4 elements, we will select a sample of 2, which means that the sample has 2 elements. And these 2 elements are to be selected from the population with 4 elements. And the sample is denoted by small n, and small n is the sample size or the number of elements in the sample. And in this example, small n or the sample size is 2. We answer letter A, how many different samples can be selected? Or how many samples with each sample containing 2 elements can be selected from the population with 4 elements. Now, in this problem, we will use a counting technique known as combination. The other counting techniques are permutation and multiplication principle. But for this particular problem, we will use combination because order is not important in selecting a sample of 2 elements from 4 elements. As long as you have 2 elements in the sample, the arrangement of these 2 elements or order of these 2 elements is not important. Thus, we will use combination, which is defined as the arrangement of objects without regard to order. And the formula for finding the combination of n, capital N, taken 2 at a time is given by the following formula. The combination of n population with n elements taken small n sample size is given by n factorial divided by small n factorial times quantity capital N minus small n factorial. So we find the different samples that can be selected from a population of with 4 elements, and each sample has 2 elements. That is, we will compute combination of 4 taken 2. Substituting the values of capital N and small n into this formula, combination of 4 taken 2 is equal to 4 factorial divided by 2 factorial times quantity 4 minus 2 factorial. And we simplify the denominator. 4 minus 2 is 2 factorial. By definition of factorial, 4 factorial is equal to the product of 4 and all the positive integers less than 4 up to 1. And 2 factorial by definition of factorial is equal to the product of 2 and all the positive integers less than 2. That is 1, 2 times 1. 4 minus 2 is 2 factorial. Again, 2 factorial is 2 times 1. And we cancel what we can cancel. We have 2 times 2 is 4, and we have 4 in the numerator. So we can cancel 4 and 2 times 2 in the denominator. And we multiply the numbers that are left. We have 3 times 2 times 1 is 6. Divided by 1 is 6. Therefore, there are 6 different samples that you can select from a population with 4 elements, and each of the 6 different samples will have 2 elements. In letter B, we will now list the different samples. We now list the 6 different samples that we can select from a population with 4 elements. But before we list down these 6 different samples, we denote the 4 elements by the following notations. Let E1, E2, E3, and E4 be the 4 elements of the population capital N equals 4. And we denote these 4 elements by E1, E2, E3, and E4. And we list down the 6 different samples and the observations in each sample. And one possible sample is the sample containing the elements E1 and E2. Another possible sample is the sample that contains the elements E1 and E3. Another possible sample with 2 elements is the sample containing elements E1 and E4. And the 4th possible sample is the sample that contains E2 and E3. The sample that contains E2 and E1 is the same as the sample that contains the elements E1 and E2. As we said, order is not important. Thus the sample containing E1 and E2 and the sample containing E2 and E1 are the same sample because order of elements is not important. Another possible sample is the sample containing elements E2 and E3. And the possible sample is the sample containing the elements E2 and E4. And the sixth possible sample is the sample containing the elements E3 and E4. So these are the 6 different samples that can be selected from a population with 4 elements. And in letter C, we are asked what is the probability of selecting each sample. As I said earlier in the beginning of this lesson, in simple random sampling, the different samples that can be selected have equal chances of being selected. And for this particular problem, there are 6 different samples. Hence, the probability that each of these samples will be selected is 1 over 6. The probability that this sample with elements E1 and E2 will be selected is 1 over 6. The probability that the second sample will be selected with elements E1 and E3 is 1 over 6. Probability that the third sample with elements E1 and E4 is 1 over 6. And so on until the sixth sample. The probability of selecting the sixth sample with elements E3 and E4 is 1 over 6. And the denominator is 6 for each probability because we have 6 different samples. And that's the, by definition of basic probability formula. The basic probability formula states that the probability of a sample is equal to the probability of an event This is the basic probability formula. The probability of an event is equal to the number of sample points in the event E divided by the total number of sample points in the sample space. Where in our example, the sample space consists of the 6 different samples. Hence, using this basic probability formula, the probability of selecting the first sample, S1, is equal to the sample. There is only one event or that contains elements E1 and E2 among these 6 different samples. There is only one event that contains the elements E1 and E2. Thus, the number of sample points in the event E is 1, and N of S is the total number of different samples that can be selected from the population with 4 elements, which is 6. You can actually write here N of S is 6. Thus, the probability of selecting sample 1 is 1 over 6. And the same probability applies for each of the other 5 samples. We now formally define simple random sampling. Let n, capital N, and small n be the numbers of elements in the population and sample respectively. Capital N is the number of elements in the population from which we will select a sample, and the number of elements in the population is denoted by capital N, and N is the number of elements in the sample that we will select from the population with N, capital N, number of elements. If sampling is conducted, that is, we will select a sample of elements from the population with capital N elements. If sampling is conducted such that combination of n taken and different samples, as we have shown in the example earlier, if the population has n number of elements and The sample to be selected from the population has a small n number of elements. To find the number of different samples that we can select from the population n, we use combination of n taken n. Thus, for a population with capital N elements, from which a sample with small n elements are selected, we can select combination of n taken n different samples. Again, if sampling is conducted such as this combination of n taken and different samples have equal probability or equal chances of being selected, then the sampling is called simple random sampling or simply random sampling. And the sample selected is called random sample. And that's the definition of simple random sampling or simply random sampling. And for your exercise or assignment, please do the following. Number 1, how many different samples of n equals 2? That is, each sample has 2 elements. Each sample has 2 elements. And these 2 elements are to be selected, could be selected from a population with 5 elements. List them. That is, list the number of different samples that you can select from a population with 5 elements, and each sample has 2 elements. What is the probability of selecting each sample? And this problem is very similar to our example earlier. And that completes our discussion of probability distribution of discrete random variable. And in preparation for the next lesson, please do the following exercise. Define or describe. Letter A, binomial probability distribution. B, Poisson probability distribution. And C, hypergeometric probability distribution. These are the 3 useful discrete probability distributions, and these will be our topics for the next lesson. And that completes our lesson for today. And if you have questions about the lesson today, you ask your questions in the comments below. But don't forget to subscribe to my YouTube channel, Art Calison, the channel of learning and leisure. You may also ask your friends, your classmates, and relatives to subscribe to my YouTube channel, Art Calison, so they may learn as well. Thank you for joining me in my class today in Advanced Statistics.